All right, solutions to the review for Unit 6. We have a slope field. How do we know which ones to cross out? So it's kind of process of elimination. So let's say you take a point like here, 1, 1. So if x is 1, first of all, this one has to be wrong because if it's x, that would mean all the columns would be parallel. So when x equals -3, they would all have the same answer, or -1 or -2 and so on. It's not true. If I look here at 1, 1, when I go 1 plus 1, I get 2. Well, that's a horizontal line. That answer is going to be 0. And here, when x is 0, that's this column here at 0, they would be all undefined. So the only two that are left that could be are this one and this one. Now, they both have x minus y, but one has an x. So I'm going to take a negative x value, like right here. So -1 and 2. So if x equals -1 and y equals 2, here you would have -1 minus 2. That's -3 times -1, which would make it positive. That's a positive slope. If I only went -1 minus 2, the answer would be negative, and this would be a negative slope, not a positive slope. So A is wrong and C is correct. All right, which of the following could be the derivative slope for cosine x? So first of all, if the derivative is cosine x, can you integrate that? What does that equal? So if I integrate cosine, that's sine plus c. So which one of these, if I draw it, could be sine? So sine starts in the middle and goes up. So find the one that is a sine curve. Starts in the middle, goes up and down. This one is not sine at all. It's like a parabola. This one starts middle and goes down. That would be negative sine. This one starts at the bottom, negative cosine. And this one starts at the top. This is positive cosine. So which one would be what y would equal when you draw the solution? So this one's answer is D. All right. If the size of a population is given here, this is logistic growth, which of the following is not true? The population is increasing at 250 the fastest. That's true. Half the maximum. So that one's true. The capacity is 500. That's true. The point of inflection of the y-coordinate is 250. That's actually also true. So as it increases, right? How does it go? It goes like this and then like that. That halfway mark right there, where it's the increasing the fastest, is a point of inflection. Which one's wrong? Is this one. So if you looked here, that's what C equals. Well, C does not describe the initial population at all. So C is a constant. We can find different. So 9 is not the initial population. All right, write the correct logistic equation for this initial population. So the initial population is, so first of all, I want to write down, what is the logistic again? And then what information do I have? So the initial population is 10. The carrying capacity is 40. So if I plug in 0 for the initial population, e to the 0 is just 1. That's it right there. So 40 divided by what is 10? That's 4, right? So C would have to equal 3 for that to work. So already we know C is 3. I know that M is 40. I don't know what K is yet. So in order to find K, I need to plug in what I have here. So after 1 year, so in that case T is equal to 1, the population is 15. So I'm going to write this equation down. I'm going to have to use my calculator. So again, the maximum is 40, and it's 1 plus 3e, and I don't know what k is. But I know that m is 40 and t is 1. So 40 times 1 is just that. And I have to use my calculator and solve for k. So I'm going to do that right now. So I'm going to go Menu, Algebra, Solve. And I'm going to type that in. So 15 equals, and that's 40 1 plus 3e to the negative k times 40, or 4 negative 40k would have been just as easy, comma k, and then solve it. So the k is 0.015. So I want to put in the whole thing now together. So this is the actual answer with k involved. And I have to actually multiply these together. So I'm going to take that answer times 40. Oops. So if I go 40 times 0.015, I get 0.6. So I'm going to use 0.6 there. So we have the carrying capacity, 1 plus c is 3, e to the negative, and we just said it's 0.6t. And then put it all together. Awesome. All right, turn the page. All right, if the growth rate is given here, another logistic, what is the population's carrying capacity? So I need to factor out to find that out. So I'm going to factor out 0.0003p. I'm going to use my calculator to divide. So I'm going to go 0.00303 divided by 0.03. It's like 100 or something. No, 0.01. What? The other way around. There, 100. I was just putting it the wrong way. So if I go 100 times this, it would move the decimal over twice, so it does match. And this matches. Anyway, the whole point is the maximum capacity would just be 100 by factoring it out properly. You can also press the factor button on the calculator and do it that way. Number 6. But if you factor it, it may not factor out the 0.0003. Like you have to factor out the number in front of p squared as well as the p. Okay. 6. The shaded regions shown at the right are here, 2x squared and 3 to the x. So we have a parabola and we have an exponential. Find the x and y coordinates of the 3 points of intersection. All right. So I'm going to graph these. It's good practice. Oops. Turn it back on. That's the on button. All right. If you have something, you can go menu actions and get rid of it. And then press tab. And then the first one is 2x squared. Let's do it. And the second one is 3 to the x. Let's do it. Now, for this one, do they intersect right there? I don't think they did. I think they only intersect at the one point. Interesting. So let's go back. Let's say that you go menu, algebra, and solve, and you make them equal to each other. So go 2x squared is equal to 3 to the x, right? Oops. Move the cursor, comma x. Yeah, there's only one solution there. It only is there at negative 5.28. So if I go back to the graph and I go menu, analyze, and point of intersection, that's 4, I'll start to the left here, press down, and then go over it. The x and y coordinate are right there. Negative 0.5288. And the y coordinate, you can truncate, is 0.559. Now this one looks like there's more. So let's say on your exam there's more. Each one you would have to go left then right and find each one, left, then right, then find each one and write down each answer. All right, set up an expression that gives the area of that that's enclosed. Well, I only have one point of inflection, so this is what I'm going to do. I am going to change and shift that to the right 1. So this is what I'm going to do. I'm going to change this to plus to minus 1. So I'm going to make this 3 to the exponent that, so they intersect at more than one spot. So I try to set up an equation that worked, and it doesn't look like it worked. So let's see if I do it that way. So if I change this to minus 1, shift it over. All right, now we can find that area that's enclosed right there. So now the point of intersection is negative 0.339. So I'm going to change this. So negative 0.339, and the y coordinate is 0.229 or 0.230. But there's another point of intersection, so I'm going to show you that. So menu, analyze, point of intersection. And this one's right here. Press N there, and then move over. Let's try it again, like there. And then what's the second one is right on top. I'm going to move that so you can see it. So that's 0.553 and 0.612. All right. So now with this, how would you find that area? So you'd integrate from negative 0.339 to 0.553, and it would be top subtract bottom. So in this case, the top is the red, the exponential. Subtract the bottom, which is 2x squared, and that's what the setup would be. Sorry, that would go here, and that's it. And if you wanted to, you would type it all in to find the area, but right now it just says set it up. That gives the whole area. So this would be the answer right here. All right, set up an expression involving one or more that gives the volume of the solid generated by revolving around the line y equals negative 2. So that's down here. So we have y equals negative 2. That's down here. So let's say that this is what we're revolving around. So if I do that, I have a big radius and a small radius. There's a hole there. So this is going to have pi, again, from negative 0.339 up to 0.553. And we have a big radius, subtract a small radius. So the big radius, what's on top? So in this case, what's on top there is the exponential. That's 3 to the exponent. And then you subtract what's below, which is negative 2. And then the small radius is 2x squared subtract negative 2. So again, top subtract bottom, top subtract bottom, big radius, small radius, and there's the setup for the volume. All right, put away your calculator now. What's the limit here? So the value at cosine pi over 2, that's at the top of the unit circle, right up here. That's 0. And then pi subtract pi over 2, that's 0. This is L'Hopital's rule. So take the derivative of cosine, that's negative sine, and the derivative of x is 1. And now plug in pi over 2, and it's negative. And when you plug in pi over 2, the y coordinate up there is 1. So the whole answer there is negative 1. Number 8, if you plug in 0, it's 0 over 0. So the derivative of that is 3 over cosine. If you plug 0 in, the value of cosine at 0 is 1. So the answer is 3. Here, this is a L'Hopital question. The top is increasing faster than the bottom, so this answer is infinity or doesn't exist. All right, I'm going to do part 2 on another video. All right, Mr. G Math over and out. I hope that helped. It'll be a second video for the second page. Till next time.